absolute value today. A couple of terms to get down first. So we've been talking about integers, but we haven't really talked about the technical formal definition of an integer. An integer is any number that is not a fraction or a decimal. Any number, it can be positive or negative, as we've seen, but any number that is not a fraction or a decimal. So this, where it says the set of integers, in math, a set is just a collection of numbers that have something in common. So the set of integers, we write it with the curly brackets there. And these three dots at both ends of it, it means it keeps going on in that same pattern.
Sorry, I need to get a charger. Yeah, an easy one for me. Thank you. Sorry to interrupt.
So these three dots, it means they continue to go on in the same pattern. So -4 and then -5, -6, -7, forever, all the way to negative infinity. Then these three dots mean it goes positive in the same direction, 5, 6, 7, 8, 9, 10. We can't write all the numbers that are integers because they go on forever. So that's why we write those three dots. But that's kind of the pattern to see. And notice that 0 is an integer as well. 0 is not positive or negative. It's called a neutral number. So it's just by itself, 0. But 0 and then any positive integer, any negative, or any positive whole number, and then the negatives as well. So then absolute value, what we're going to be talking about today. It is the distance between a number and 0. And the key for absolute value is the word distance. We're going to talk about that here in a second. Absolute value is the distance between a number and 0. So one way that you can think about absolute value is visualizing it on a number line. The number -3 is 3 spots from 0, and so we think about that as absolute value. Doesn't matter if it's negative or positive, how far away is that number from 0? So that's one way you can visualize it, is looking at a number line. Okay, so some important things about absolute value. So absolute value, it is not the opposite of a number. It is not the opposite of a number. Once again, absolute value is the distance and distance is always positive. Since absolute value is distance, and distance is always positive, then absolute value is always positive as well. Okay, so making sure we know and we remember, distance is always positive. If I was going to walk from here to Abdullah's desk, all right, let's say that was 10 feet. So I've walked 10 feet, right? If I walk backwards, back to where I started, have I walked negative 10 feet back here? No, I've walked how many feet? So in total, I've walked how many feet? 10 there and 10 back, so I've walked 20 feet. It doesn't cancel out just because I walk backwards, right? Who walks to school? Okay, Taylor, let's say it's a half a mile from your house to school, right? If she walks a half a mile to school and then doesn't feel like coming, walks a half a mile back home, does that mean she's walked 0 miles because she ends up where she started at? She's walked half a mile and half a mile, so in total she's walked 1 mile. Okay, so distance is not positive, is not negative. Distance is never negative. Okay, it doesn't matter if you walk forwards or backwards. Doesn't matter if you start and finish at the same spot. If you travel somewhere, it's always positive. Okay, so make sure we remember, distance is always positive. Distance is never negative. Okay, so absolute value, since it's distance, absolute value is always positive as well. So the absolute value of -4, this -4 would be +4. So the absolute value are these two lines around numbers. That means whatever is inside, you turn that positive. Remember, absolute value of +4, is absolute value the opposite of a number? No, we said it is not the opposite, so we don't turn this to -4. That's the most common error that's made. This would just stay as +4. So notice, we're not just making a negative positive and a positive negative. Every number inside the absolute value bars is going to become positive when we take them away. Second thing, a question like this, where the absolute value is around two numbers and we're subtracting them. Absolute value, so write this down somewhere, is the same as parentheses in the order of operations. Absolute value is the same as parentheses in the order of operations. In other words, what step in order of operations do we do parentheses? P for parentheses comes when? First. So when should we do absolute value if we're doing a problem? first. Yep. Take the absolute value first, and then we can continue on with everything else. So these are the same as parentheses, which means take the absolute value of -5, so -5 becomes +5. Take the absolute value of 2. Does 2 change? Nope, because absolute value is always positive, because it's distance. So now we just do 5 minus 2, which is 3. So we're taking the absolute value of each number first, and then we add, subtract, multiply, or divide. Basically, we've got to get rid of the absolute value bars before we can subtract these two numbers. Okay? Any questions? All right, you all go ahead and do these 3 on your own. Do those 3 on your own. Okay, so on our first one, 8 minus the absolute value of -10. Do we need to do anything with 8? Nope, because there's nothing around it. So 8 stays 8. What's the absolute value of -10? +10, right? Now we do 8 minus 10. Go back to last week if you need to. You can change that to 8 plus -10, and then we would subtract them, and our answer would be negative because 10 is the bigger number and 10 is negative. So our answer is going to be -2, which means you can get a negative answer with absolute value. You can get a negative answer with absolute value. So notice, did we do this right? Did we change -10 to +10?
Yeah.
After we've done that, does it matter if it's negative or positive? Because do you have any absolute value bars after this step?
No.
You don't. So then you just do it normally. Okay? So you can get a negative answer if you've got absolute value bars, like this one. Okay? So let's look at our next one. 2 plus the absolute value of -3. 2 doesn't change. The absolute value of -3 needs to become +3, and then 2 plus 3 would be 5. All right, and then we've got the absolute value. Take the absolute value first. So the absolute value of -6 is just 6. The absolute value of -4 would be +4. And then we're still going to subtract here. So it would just be 6 minus 4, which is 2. So notice, are we changing subtraction or addition signs or anything like that? Are we changing any positive numbers to negative? Any positive numbers becoming negative? Absolute value is always positive because absolute value is distance, and distance is always, everybody, positive. Remember that. Distance is always positive. Okay, so there's a couple more that I want to look at together. What is different about these problems from the ones we just did? Look at the absolute value bars. What's different about them? Dula?
It's in the middle.
Yeah, there's like a problem inside of the absolute value bars. So if you see something like this, remember it's like parentheses, okay? So what I'm going to say for this is work from the inside out. Work from the inside out. So first of all, remember it's like parentheses in order of operations. So we have to get rid of these absolute value bars first before we can do anything else. So if we had 5 minus 8 inside parentheses, we would do 5 minus 8 first, right? Do the same thing. So 13 is going to stay here, and then this plus 3 is going to stay here. So treat 5 minus 8 like a regular problem. Do not change anything to positive yet. Okay? So 5 minus 8, we could make that 5 plus negative 8. Subtract them. 8 minus 5 is 3. 8 is bigger, and 8 is negative, so it's going to be negative 3. Have we taken the absolute value yet? What's the only thing that we've done so far? Subtracted. So, do we still need the absolute value bars? Have we taken the absolute value? We have not yet. We haven't taken the absolute value. We've only subtracted. We just did 5 minus 8. So we still need the bars around negative 3. Another important thing. We can only take the absolute value if there is one number inside the bars. We can only take the absolute value if there is one number inside the bars. So whenever there's two numbers inside of here, we can't take the absolute value. We've got to keep the bars until we've got one number left. Okay? Now that we have just one number, we can take the absolute value. The absolute value of negative 3 is positive 3. And so bring down your 13 plus, bring down that other plus 3. Now, we don't have any more absolute value bars. We can continue on with order of operations. 13 plus 3 plus 3 would be 19. Okay? So work from the inside out. Take care of the inside stuff first, then work your way out. So let's look at our next one. This 6 plus, keep it there. What's different about this one now? It's different, Jake. There's two sets of absolute value bars, exactly. We're going to do what's on the very inside first. So what is on the very inside of these absolute value bars? What's on the very inside, Vincent? Negative 5 minus 7. Do that first. Okay? So if we want to come over to the side, let's figure out what negative 5 minus 7 is. Remember, negative 5 doesn't change. We're going to change subtraction to addition. Change the 7 to negative 7. So negative 5 plus negative 7. And what is that going to be? Negative 5 plus negative 7 would give us negative 12. So, negative 12 can replace the negative 5 minus 7. Have we taken the absolute value yet? The only thing we've done is negative 5 minus 7. So how many sets of bars do we need to put around this negative 12? 2 sets of bars. Good. Now let's work inside. Let's work from the inside out. Negative 12. We've got 1 set of absolute value bars. So what's the absolute value of negative 12? 12. So 6 plus, this becomes 12. How many times have we taken the absolute value? So how many sets of bars can we get rid of? 1, which means how many sets are left? 1 set is left, right? We've gotten rid of these guys. We still have the very outside. Now, is 12 going to change?
No.
Because absolute value is always positive. So this is going to remain 6 plus 12. And then we can finally add, and we get 18. So it's like parentheses, the order of operations. Get rid of the very inside and start to work your way out. Same thing with absolute value. So you guys see kind of how you got to work your way out, get rid of the bars, and then you can finish by doing whatever. Okay, any questions? All right, we got one left, a word problem. I'm going to let you all finish this one up. I think you guys can get that. Anytime you've got a word problem with absolute value, they will always give you the problem. You don't have to create it. So they give you the problem there. You just got to figure out how many feet he traveled. Okay, think about climbing up a rock wall. If you climb up and then you climb down, if you're climbing down a rock wall, are you still traveling a distance, even though you're going down? So they write negative 22, but distance is always. So what should you do with this negative 22, Jazz? Make it a positive 22, and that's why they have the absolute value there. So they're saying it's represented by negative 22 because you're going down, but if we put absolute value bars around it, that becomes 30 plus positive 22, and 30 plus 22 would be 52 feet. So, very important. Is the absolute value the opposite of a number? Is it just turning a positive to a negative or a negative to a positive? It is not. Absolute value is the distance, and distance is always, which means absolute value is always. Very good. So make sure you don't just flip the numbers. Make sure it's always a positive number after you take the absolute value. Okay? Any questions? Okay, you guys can go ahead and get started on these problems.